channel Knowledge Star Continuous Knowledge Excellence. My name is Karuna Singh. In this video, we will get to know about the electrochemical cell assembly. Now our expert Professor Himatri B. Buhidar, who is associated with National Center Excellence in Agro Nanotechnology, Delhi Deccan Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobiointerface science, soft matter science, polymer physics, biophysics. Will explain you in detail about this topic. So, to get complete information, watch full video without skip.
Now, based on what I have said, we have a cell now which looks like this in an experiment in the lab. You have a electrolytic cell here containing various electrolytes, and there are 3 electrodes introduced into the cell. One is a working electrode, one is a reference electrode, and third one is a counter or auxiliary electrode. What is the role of the electrodes will become very clear soon. You have a electrode assembly or electrochemical cell which has 3 electrodes inserted into it. Now, diagram was simplified now. This is my electrochemical cell. We have one electrode here, 1, second electrode here, 2, third electrode here, 3. This is called the working electrode. Everything that we want to do, that basically is sensing, that is done here on the electrode, working electrode. We have to design this electrode for our use. All measurements are going to be done with respect to a reference state, that's why we need a reference electrode. Often we need a third electrode because of the reason which will come up later during this presentation. Okay, now between the working and the reference electrode, we apply a ramp signal, voltage signal like this. This is time potential. So from T0 to T1, the potential increases to a maximum value. T1 to T2 decreases the same slope. This is increasing slope, decreasing slope. Now this is repeated, T2 to T3, here T3 to T4. So between 1 and 2, we have this potential increasing and decreasing in a periodic fashion, while the counter electrode is doing something else. Now we realize that if you take it as a simple electrical circuit, when you increase or decrease the voltage, the current that is flowing through it, measured by this ampere meter here, is going to change. And that is what is your electrical signal. So depending on what is the current here, you should be able to know what is happening inside the electrochemical cell.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much, because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshop on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in, where you can easily enroll in the workshops. So just check it out right now.
Now look at this slide. This is my working electrode. I've amplified it. This one that you see, this gray block here, this one. This is in contact with the electrolyte here. Suppose the electrode surface is negatively charged here. Okay, it's a densely negatively charged surface. What will happen is the positive ions, hydrated positive ions, they will come and sit closer to the negatively charged surface of the electrode here, very tightly bound through electrostatic forces. Okay, then you will see, because this is positively charged, a weak negatively charged force will act beyond this and to attract all the negative ions or counter ions to come closer to it. Then you will see this green negative ions, hydrated negative ions will try to come close to this one. And then they will create a structure here of, see, this is the negative ions here, positive here, then predominantly negative, and then there is positive, and slowly diffuse into the liquid and become homogeneous after a while. But for some distance from the surface of the electrode, we are going to see a tightly bound layers of counter ions. And this is what is called the electrical double layer in electrochemistry. And this is equivalent to a capacitor in an electronic circuit. You have a negative plate and you have a positive plate, and you have dielectric in between that. That is a capacitor, nothing else. So now your electrode is behaving like a capacitor, plus then the diffused liquid, the ion that you see here beyond this double layer also has got your analytes. Now for your analytes to come to the surface of the electrode to be detected, first they have to cross this solution barrier here, all that. Then they have to pass through the capacitor, also some resistance there, and they'll reach the surface of the electrode to be detected. So all that will be reflected in the electrochemical signal that you will get from the electrochemical cell. Okay, so realize the fact that your electrochemical cell now is equivalent to a capacitor and a resistor in some conformation, if you compare it with an electrical circuit. Okay, now same thing has been written in a very different manner here. You have the working electrode here. This is the reference electrode. I told you between these two there is a resistance there. There is some amount of current flowing between the two, and multiply resistance with the current, you will get a voltage drop between the working and the reference electrode here. When the experiment proceeds, there will be more and more of analytes coming and sitting on the surface of this. Resistance will increase. Therefore, the potential drop will also change with time. So the current that you are measuring or the sensing that you are doing will get disturbed because of the changed potential between the two. To take care of that, an auxiliary electrode is utilized. The job of this is to take out the excess of the electrons from the circuit and maintain a constant potential difference between reference and working electrode all the time. That is the job of the auxiliary or the counter electrode. Okay, so counter electrode is required to maintain a constant potential difference between working and reference electrode. Reference electrode is always there. All measurements are done with respect to the reference electrode. And working electrode we need to design. We don't get a commercially designed working electrode. We need to design our own electrode using the Nano platform.
I hope you liked this video. Here, I would like to give you an important information that Nanoscience and Technology Consortium or NSTC organized the nanotechnology workshops on very interesting topics. Also, I would like to tell you about the initiatives of NSTC in which you can also be a part of. Mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs or customized training programs, workshops or customized workshops. So yes, that's all. And yes, there is one more thing, that if anybody wants the recording of the previous video, then they can contact us on info@nstc.in. Further, if you want to enroll in the upcoming workshop, so you can go to the website www.nanoschool.in. Further, I would like to tell you that if you want to see these type of videos on this channel, so please do subscribe to the channel and please do comment. We will definitely reach out to you. Thank you.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.